Hello, thank you everybody. My name is Andrew Daley. I'm a product and engineering manager at a startup here in Tokyo called Yoii. And today I'd like to talk a little bit about agentic prompt and context engineering as we begin to let the LLMs write our context. For those of you who have experience building agentic systems over the past year or two, this might not be all news for you, but I do hope to share some of the latest research of the last year with you. And for those who are not familiar with agentic systems, we started to call them, basically this is us talking about as we move away from the previously deterministic way in which we built systems in the past, as we begin to build these swarms and groups and systems of agents, how we harness them, how we orchestrate them, and how we manage their context. So before we jump into that, obligatory introductory slide about me and the company I work for. As I mentioned, we are Yoii. We are a startup who funds other startups. So we present an alternative type of financing that is technically neither equity or debt financing. It goes by a couple different names, sometimes revenue-based financing, merchant cash advancing. But the basic idea is that we forecast out companies' revenue. We then purchase a share of that revenue that is then paid back over so many months, plus a fee that we take that is not quite interest. So typically our customers are startups that use us either as bridge financing between venture rounds or as just fuel for their fire, where they might typically go to a bank. Our real points of strength are that compared to a VC or a bank, for much faster. Typically, we can have money in the bank in about 2 weeks compared to the months that a venture round or a bank financing might take. And we're just a hell of a lot simpler, right? We're not going to reel you like a mega bank will. We're not a VC. We're not going to take a massive chunk of your valuable equity. So that's all of us just trying to do our best to accomplish our mission, which is to boost liquidity in empowering daring entrepreneurs here in Japan. As I mentioned, I'm an applied A product manager and now engineering manager in Sento Enthusiast. So that will all be important much later as we look at the case study I'll present, but for now, let's return to the topic. So if we can all think back to when this all kind of started, maybe 2020, 2021, there was a lot of talk about prompt engineering. There were people making six-figure USD salaries in order to tune and write just the best prose that would give the best results to these agentic systems. Some good did come out of that. We got in the habit of prompt chaining and developing these kind of chain of thought habits for these systems. We also began to evaluate our prompts against golden data sets or question sets. For those of you who are unfamiliar with these are often ways in which we will evaluate the systems that we build. They are effectively just a list of prompts and scenarios that an agent might encounter out in the real world. These can be FAQs they'll see a lot, or they may be edge cases that we want to make sure that we cover. But this is typically nowadays how many companies are evaluating these systems as we build and grow them. And then, of course, this also kind of launched off agentic tool usage, which I think we're all very familiar with now, using things like MCPs. However, the bad was that these were just massive walls of texts in single formatted strings. They were versioned in Git, often with just a comment like changed prompt. And I think most importantly, different prompts perform differently on different models. At the rate which models are coming out nowadays, the idea that every time we change the model, our entire context breaks is kind of unacceptable. So what we've, I guess we'll start with just an example of what this might have looked like. This was actually OpenAI's prompt for the SWE benchmark they wrote for 4.1. As I mentioned, it's clearly just a massive string. It's about 9,000 characters, and it appears to be written by a human. Someone was kind enough to break down what this prompt actually was. You can see it does have some component parts, right? It starts with just a task. It's got some chain of thought instructions, just a ton of detailed context and instructions, some tools, and eventually more formatting than I would have expected. This is important for us to think about as we continue over the talk, because you can see that we can really break down what used to be this massive chunk into modular composable pieces. So enter DSPy, which is a framework that came out of Stanford and Berkeley a couple years ago, with the idea that we should be programming, not prompting, language models. Again, moving away from this idea of prompt engineering. The idea, as in traditional machine learning, is that we should write tasks, not prompts. We should be writing objective functions that we can then optimize towards. So in this case, we just define the task in relatively clean language, or as just a simple input and output. And then we let the LLM do the optimization. Optimization is not human strong points. That's what computers are for. We should focus on clearly defining a problem in the evaluation, and then let the optimization be done by the computer. We also want to modularize the solution. We want to break this down into its composable modules, and then train and optimize those modules to optimize the larger system. This is all pretty standard software development practices that we should all be familiar with. We've applied this to code for years. We want to keep it modular, ensure separation of concerns. We want to avoid vendor lock. We want to make sure that we're using version control properly, and in general, parameterize and optimize our code so that as a team, we can build it alongside better. Under the hood, what goes on in DSPy is there are basically two types of classes. There is a signature, which is the task, right? This is the objective function. It's typically of an input and output format. For example, it might just be given baseball player is pitcher, yes or no. These are, like I said, defined as a custom class, and they are executed by modules. Modules are the trainable runners that generate and run these prompts. They are the part that is optimized, and they come in various flavors, which I will share later, but they can be something like predict, like in this case, it can be a chain of thought that is just some sort of thought that you'd like to run this module through, or it can be a react, which is a tool usage, right? Given in this case, react using this tool. And I will say this many times, but they are once again modularized for optimization and composability. This is the OS code slide I present today, I promise, but I did want to give you just an idea of how simple this is, right? So to start, we can define a signature. In a case like ours at Yoii, it might just be assess financials for a company that's applied. The doc string is passed as context, so when we say it's all written by AI, that's not entirely true. We do want an opportunity for the human to give even just a little bit of direction here. The doc string is an opportunity for that. But after that, like I said, it's a set of input and output fields. I say fields because, again, these can be multiple. For example, in our case, we might take a combination of the customer's finances as well as our own financial risk assessment policy. And then the output would just be risky or safe, potentially. We can also here add another descriptor for a little bit of human direction if we like. And we can also get an output field that's just confidence, low, medium, high, right? These are all very understandable sorts of inputs and outputs, where we are shifting now towards the humans focusing on defining the problem, which is often really considered to be the software engineer's real job, and leaving the optimization to the systems. We then call that signature via a module. In this case, we call a chain of thought module to evaluate the assess financial signature. And then it returns what we need, just given finances and policy. Very, very straightforward. So what's going on in the background is we just provide signature and module, and then DSPy creates a system prompt on its own. This is created, but is frankly rarely read by humans. It looks like a lot of the prompts that we may be familiar with if you've written prompts yourself in the past, as we used to write these larger system prompts, except now we've abstracted this away too. So, as I mentioned, there's lots of types of modules. There's a simple predict, like is picture. There's chain of thought. There's also some more complicated options. For example, you might have a multi-chain comparison where you might have multiple different chains of thoughts and answers, and you could have a kind of LLM as judge component that can compare these answers and choose the best one given its own judgment. This is pretty similar to as we might remember from ChatGPT asking us to choose which answer it preferred. There's also a majority option where, given a predict, if we want to make our predict function more robust, we might ask the system to predict 5 times and then take the majority. This really allows us to begin kind of pulling these components together. And as Paolo said earlier, focus more on putting the puzzle pieces together rather than worrying about the actual coding. And then also we can just write custom modules as well. This is designed to be very, very customizable so we can build to the solutions that we need. So the big takeaway for this part is that also there's always going to be a new model, especially now at the rate they're coming out. The idea that we have to change our entire system every time we upgrade the model is completely unacceptable. With this new system, when a new model releases, you just port your architecture to re-optimize. It then re-optimizes for that specific model, so we can very rapidly iterate and try new models as they come out and see which one evaluates best. Of course, always just evaluating towards our Bolden data set. So as kind of a case study, I'd like to walk through kind of how this works at Yoii. Our main product is called Yoii Fuel, like I outlined earlier. And the basic flow is that a customer creates an account. They upload their data. This would be their P&L, their balance sheet, their cash flow, their bank statements, things like that. There is then a screening process. Apologies for the Japanese. Previously, this was a very human process, right? The human would look through the balance sheet and the P&L, and they would take in all this information, maybe even have a short meeting with the customer to verify some details, and then make a decision. If that customer passes the screening, we then get their funding to them. So where we've decided to focus for this is this screening process, right? There is not as much art to this screening as many financial risk analysis people would have you believe. It's all relatively rules-based. It's all very, very policy-based. It's really ideal for a system like this to begin to tackle. So we created a product called Odin, Optimized Decision Making for Investment and Negotiation, with basically two main goals. The first is human augmentation, right? Help our risk assessment team make better decisions faster, and then also move toward fully automating these decisions when we can. It follows much of the same process, right? Pulls data from the financial software, our software, the internet, OCR pipelines, feeds all that to a decision engine, which returns the decision, its reasoning, and its confidence. And then that is, at this point, presented to the examiner for assistance in making the final decision. So what does that look like? Within DSPy, it looks a little bit like this, right? So we start by creating our determined decision signature, right? We start with the objective function, determine if this company is a good investment or not. That is then executed by the decision program module. And that's all wrapped within, or that all wraps around individual chain of thought signature modular pairs that are designed to reflect the human thinking processes within our financial risk analysis process. So we can wrap all of these individual signatures within the larger decision in objective function, which is determine if this is a good investment or not. So this is all modeled around the same human processes that we have, except that now all of these prompts are evaluated against our evaluation data set. So we don't have to go and tweak them as soon as we run this optimization. We know how it's going to perform on our evaluation data set, and therefore hopefully in the real world. So looking back at this chart, we can see that we've now addressed a couple of these things. We've got the task, we've got the chain of thought instructions, we've made some progress on the formatting, but there's still a couple of things missing, right? First is just kind of a persistent knowledge base, right? The prompts themselves are not persistent knowledge. It's not memory. People who are working in these systems or even around these systems have probably heard about things like RAG that have come around over the past few years. This kind of memory problem has been a pretty consistent issue that DSPy does not solve. Additionally, this is a batch process, right? It's not learning online. It's not actively taking in the new information and data that it receives. So we do have to kind of consistently re-optimize this thing as we go. And these are not really prompting issues. We're starting to get into the world of memory, which has been around in systems for a long time. If we've used Claude Code, right, we can see that it does store little memories. It has some degree of persistence, but I think this is also, at least personally, where I get frustrated with it. And this is kind of where these systems are evolving towards. How do we online consistently improve this memory? So we're now getting into this section, right? Starting to crack into the detailed context and instructions section. And as we do this, we move away from this idea of prompt engineering towards larger context engineering, which is what we refer to it nowadays most as. We're from basically a single string written by a human or LLM that is static in nature to an entire context window assembled fresh by the system per request. It is dynamic. It can take in the current context of the current situation and act accordingly, right? So we're prompt engineering optimized like a noun, like a thing. Context engineering now begins to optimize a verb, a system, the way that we actually approach these things. So enter Agentic Context Engineering, ACE. This was a paper from Stanford Berkeley in October of last year, alongside the DSPy team. It creates a playbook of policies for the LLM to reference as context. These are strategies, rules, code snippets, whatever they might be. Where this has differed from memory systems of the past is that it begins to apply these same principles of modularization and reflecting actual human thinking, right? Where previously Claude may go just change a word here and there within our memory system or within our prompts. This now begins to break that down into modular solutions. To give you a better example, here is an example of what these would actually look like from the paper. Each policy is a discrete bullet point or strategy for making a decision, and it's stored as JSON. It's a very, very simple JSON object. They're all human readable and editable. You can go in and create or delete a policy if you'd like. But the real kind of breakthrough here was making them modular so that it is easier to update them online. We don't have to rewrite the entire context window every time we want to change some policy. We don't need to worry about vectorizing it. This is particularly important for types of memory that are procedural, where procedures might change, which is why, in particular for us at Yoii, it's been a particular interest. The general architecture suggested in the paper has three basic models. There is the generator, reflector, and curator. The generator is the actual thing that is doing the thing. It generates the output that is desired to the customer. It starts by pulling in the playbook and then executes the task. The reflector then reviews each generation and suggests edits, right? It is the kind of reflector, right? It takes what it has seen and thinks of new ways that it can improve. And then there is a curator that takes the suggested edits and updates the playbook via small modular edits. Do we need to remove this thing? Do we need to add a thing? Right. How this might look would be an architecture like this. I will preface this all by saying, frankly, we have not yet implemented this at Yoii, largely because the people at DSPy and ACE have said that they're already working on delivering a library for this. I don't think really intended for people to actually build this themselves. I'm very excited to see the addition of the ACE module within the DSPy library. But for fun, today, we can look at kind of what this might look like, where once again, we can wrap our decision signature in a larger one, right? If we created a generator module, it could execute this same determined decision signature. It has the same objective function. It's trying to solve the same task, so we can reuse that signature. And then we basically just would create reflector and curator models here. And then additionally, I've kind of called this a changer. I would imagine that the actual changes to the JSON will be rather deterministic. That's probably up to people like Stanford and Berkeley to figure out. But this would be kind of the rough idea for the way that we would implement this. And it is suggested by the people in the ACE paper. They suggest that we use systems like this to implement their system. It's almost certainly the way they're doing it right now with the library. So ACE solves most of the problems we had remaining, right? It gives us, most importantly, an evolving editable, auditable knowledge base. It's finally bringing this idea of memory management, of statefulness, to online learning, so that this is not something that we, the engineers, need to be managing at a very minute level. As long as we have our evaluation set properly aligned, the LLM can learn what it needs to learn. It can store what it needs to store, and it can do it all online as it gets more data by itself. It does what memory's done for a while by putting domain-specific and necessary knowledge knowledge and policy into context without confusing the reasoning. And once again, reinforces modularity and separation of concerns. So as I mentioned, these are meant to be used together. DSPy optimizes the program itself, while ACE optimizes the environment, right? How do we manage the actual context window, what gets put in and what does not? So today's key takeaways are basically that as we build agentic systems, context should be treated like code and data, or some biases. not just strings, right? These are things that should be optimized. They should be modular. They should have clearly defined I/O. They should be stored and retrieved as needed. They should be optimized based on training and evaluation data. They should be portable across platforms and models. And we should be making sure that as we continue to build out these systems, especially as teams get larger, the changes we make should be incremental conversion. So I believe that's all I had for today. I'd love to hear any questions you have about the system or just AI in general. Thank you.